Alrighty, in today's lesson, we're going to be looking at 8.2, which is sum and difference identities. All right, so just like in 8.1, we're going to look at some new identities that's going to help us simplify answers and use to solve some trig functions. So for starters, we'll start with the sign identities. All right, and we have now in the book, they use U and V. I feel that that can kind of be confusing in your notes. I'm going to use X and Y. Same concept, just different letters. So sine X plus Y will equal sine X cosine Y plus cosine X times sine Y. The next one is sine X minus Y. And this one's just going to be sine X cosine Y minus cosine X sine Y. Cosine identities are going to be cosine of X plus Y is equal to cosine X cosine Y minus sine X sine Y. And then your cosine X minus Y, again, just like in the sine version, is the same thing. We just change the sign in the middle. So this would be cosine X cosine Y plus sine X sine Y. And then you have your tangent identities. And they are tan X plus Y equals tan X plus tan Y divided by 1 minus tan X tan Y. And then your tan X minus Y, again, just like in the others, the only thing that's going to change is the sign. So this becomes tan X minus tan Y over 1 plus tan X times tan Y. Okay? So the goal is to try your best to memorize these so you're able to use them as identities. Okay, so with that, let's go into some examples. And we'll look at number 2 first. It's in this first set of questions, it says use the sum and difference identities to determine the exact value of each of the following expressions. So we are given sine pi sixth plus 3 pi fourths. Okay. If you were to try to add these, it might not actually produce an answer for us. In this case, this would be, what's that going to be, 12? So that'd be 2 pi over 6, and then 9 pi over 12. That would give you 11 pi twelfths, right? We don't have a twelfths on our unit circle. So for starters, it separates it for us. Later on the road, you're going to have to separate it on your own. Now, we do have a pi 6 and a 3 pi fourths on our unit circle, but using the sum and difference identities, we can use this to separate this. So our sum identity for sine will be, this will basically be your X and this will be your Y. So this will be sine pi sixth times cosine of 3 pi fourths plus cosine of pi sixth times sine 3 pi fourths. Now we know all of these identities according to our unit circle. Remember, pi 6 is the same thing as 30, which is the same thing as square root of 3 over 2 and 1/2. So I can come over here and at sine pi 6, that is a 1/2. 3 pi fourths, all right, well, this is 1, 2, 3 pi fourths. So that'd be a negative square root of 2 over 2, comma, square root 2 over 2. So kind of locate where you're at and then write your 3 known fractions for each section. So this will be a negative square root of 2 over 2 plus cosine was the square root of 3 over 2 times the square root of 2 over 2. Again, pulling from our information. And cosine's the x value, sine's the y value. Now I have a problem where I can solve it. So I can multiply that. That'd give me negative square root of 2 over 4 plus the square root of 6 over 4. And they just want to make you write this as one giant fraction. So this would be negative square root of 2 all divided by 4. So that would be the exact answer. They don't want decimals. They want it with the radical sign. But that's how we can use the sum identities to help us solve what the solution is. All right, let's get it a little bit harder. Let's do one where it doesn't break it down for us. So let's look at number 13. Sine of 165 degrees. I don't have 165 degrees, so the goal is to try to come up with either two things that add or subtract to 165. Let's see. Get 90, 75, we don't got 75. Take a 60, that's a 105, we don't got 105. Let's take 45. Okay, yep, we could do that. What's 120 plus 45? Again, you're just coming up with two things that either add or subtract to that result. Now, what I did to kind of go through this process is I started at the 90 because I thought those are easy, coordinates, 0, 1 type thing. But then 90 had 75. I knew we didn't have a 75. So then I worked myself to 60, and I saw that we had 105. We didn't have that. And then I worked to 45, kind of working ourselves down. If none of those would have worked, I would have started going this direction and just kind of picking numbers until I could make it work. And if the adding didn't work, then I moved on to subtracting. So with this said, I can now plug this in as the same concept. So this will be sine of 120 times cosine of 45 plus cosine of 120 times sine of 45. Again, using the unit circle, 120, this would be basically 60. This would be 120 right here. So this would be negative 1/2 because we're closer to the y-axis, comma, the square root 3 over 2. And then 45 is located right here, and that's dead in the center. So that would be the square root of 2 over 2, comma, the square root of 2 over 2. All right, so I come and I go and I see that sine is going to be the square root of 3 over 2, 2 over 2 plus, that's going to be a negative 1/2 times square root of 2. So this gives us square root of 6 minus or in that negative. Right, which gave me the square root of 6 minus the square root of 2 over 4. And that's it. You'll kind of see a lot of these answers will look very similar because there's only so many ways we can multiply numbers. All right, let's do another type. Let's look at number 21. Number 21 says cosine of 25 pi over 12. All right, our goal, again, same concept, come up with two fractions off the unit circle and which 25 pi 12ths can turn into. So I'm going to think of 12ths. So this right here, this is pi 6, which can be 2 pi 12ths. This right here is pi 4ths, which can be 3 pi. Man, I don't know why I keep doing a radical sign. 3 pi 12ths. This right here is pi thirds, which is 4 pi 12ths. this is pi halves, which is the same thing as 6 pi 12ths. That's not going to give me too much. Let's kind of keep going. This would be 2 pi thirds, which would be the same thing as 8 pi 12ths. 8 and 6, that's 14. Let's keep going. So this right here would then be 3 pi fourths, which would be the same thing as 9 pi 12ths. That'd be 18. That's not going to do me anything. This right here would be 11 pi 6, which will give me 22 pi 12ths. All right, so that gave me 3, 9. Why did I get 11? Hold on. Let's try that again. All right, this is going to be 5 pi 6. So that'd give me the same thing as 10 pi 12ths. Again, I'm getting closer. I'm just going to draw another one so I can do the other half here. This right here would be, let's see, so that'd be 1, 2, 3. What's this? 4 pi thirds. So that would give me 16 pi 12ths. All right, I think I might be able to work something with that. I might have been able to go earlier than that. So this one was 10. No, this one was 9. I would need a 6. Oh, I could. Man, I went way too far. So I can actually turn this into 9 pi 12ths plus 6. No, I'm multiplying because that's only 15. That's why I kept going. Hold on. All right, so yeah, so that's 10, 10, that's 20. Here I got 16. So I just need 9 more. So there we go. So I can write it like that. So 16 pi 12ths plus, because again, that would be 4 pi thirds, 5 pi thirds, and 6 pi thirds. So this would be 210. And then the next one was 225. And then 240. And then 270. All right, sorry, just doing a little extra in my head. All right, so that's 16, and then I need the 9 pi right there. So 9 pi 12ths. All right, so 12ths are probably the worst. And that, well, not so bad because it's 25, but I had to get to 25. So, and you could have maybe done that in a subtraction sense, but I feel like adding is always the easiest. So what this is 16 pi and 9 pi gives me 25 pi. Now I want to simplify them back to their normal. So this is the same thing as cosine. 16 pi over 12s is the same thing as 4 pi thirds. Again, 4 goes into each one of those, plus 9 pi 12ths, which was the same thing as 3 pi fourths. Right? That right there, again, multiplied by 3 gets this right here. So this is what I'm looking at. So when I work this problem out, cosine, sum of cosine is cosine 4 pi thirds times cosine 3 pi fourths minus sine 4 pi thirds times sine of 3 pi fourths. Now in a second, oh, I guess I still need that one. In a second one, I'm going to go to my results here. I needed 4 pi thirds, which would be a negative 1/2 and negative square root 3 over 2, because I'm closer to the, oh, I lied. I'm closer to the x-axis. So my x value needs to be this larger. So this is negative square root 3 over 2 and negative 1/2. And then over here for the 3 pi fourths, we talked about this already, but it's negative square root of 2 over 2 and positive square root of 2 over 2. So when I write my results, cosine at 4 pi thirds is negative square root 3 over 2. Cosine is negative square root of 2 over 2. minus 4 pi thirds would be negative 1/2 times square root of 2 over 2. So then I do the math, and that's going to give me a square root of 6 over 4. And that's all going to give me a positive square root of 2 over 4, which then gives me a square root of 6 plus a square root of 2 over 4. All right, so that's probably just about as hard as it's going to get, mainly because you have to turn these fractions into the same denominator, work them all the way until you finally get something that works, versus it just being so straightforward. All right, let's look at a different type of question so you have as many examples as possible. Let's look at number 27. It says, suppose that sine alpha is equal to 4/5 and sine beta is equal to 5/13, and both alpha and beta are in quadrant 1. That just means that they're both, so when you see that they're both in quadrant 1, that means they're just both positive. Find cosine alpha minus beta. So when I go back to my stuff, I see that this is then cosine of the first term. So that's cosine alpha, cosine beta, plus sine alpha, sine beta. So I'm going to use this right here. The only issue is I'm only given this. I have to go calculate the cosine. So what you have to do is you have to build some triangles. This one be the alpha one. So this is SOHCAHTOA. So this is going to be opposite is 4, hypotenuse is 5. Do the Pythagorean theorem, a squared plus b squared equals c squared, but hopefully you also realize this is just a 3, 4, 5 triangle. So 9, 16 gives you 25. So then that means then that cosine alpha, which is ka, would be the 3 over 5. So now I got cosine alpha. Now I got to do the same thing for beta. And again, it doesn't matter where you put beta at, but I see that this is going to be, again, so that's going to be 5 over 13. Do a squared plus b squared equals, oh, my bad. A squared plus 5 squared equals 13 squared. So that's a squared equals 169 minus 25. So that's a squared equals 144. So that means a equals 12. So then that means that cosine of beta is, again, is adjacent over hypotenuse. So that's going to be 12 over 13. That's why this part's important, because now I know that these are also going to be positives. All right, so cosine alpha is 3/5. Cosine beta is 12/13. Sine alpha was told to us as 4/5, and sine beta was told to us as 5/13. So then we work it out this way. So we don't have to use the unit circle. We just have to be able to find the missing angles from what's given to us. So this is going to be 3 times 12, which is 36, 5 times 13, which is 65, plus 20 over 65. So that will give us 56 over 65. Whoa, man. Glitchy today. 65. There we go. All right. And then reduce, obviously, if you can. Typically, if you could reduce, you would reduce at this stage here, but reduce if you can. All right. So let's look at some different type of problems. Again, I want to give you a good type of each one. So let's look at number 33. It says use the sum and difference identities to rewrite each of the following expressions as a trigonometric function of one angle and then evaluate the result. So here we go. So this is going to be sine 15 degrees, cosine 30 degrees, plus cosine 10 degrees, and sine 30 degrees. So what we have to do now is work backwards. So which one of these turns into a more simpler function? And when looking at it, I see sine cosine plus cosine sine. So that means this must be the same thing as sine of x plus y. So in this case, that's 15 plus 30. And so when I work this out, this real question is, what is sine of 45? And hopefully you realize that that's just the square root of 2 over 2 because it's located right here. Okay? And so basically this is just going backwards to simplify the question to an easier answer. All right, so let's look at 35. All right, 35 is given to you as tan 100 degrees plus tan of 35 degrees divided by 1 minus tan of 100 degrees times tan of 35 degrees. All right, so then again, we're now going to look at the tangent identities. And I see a tan plus tan with a 1 minus tan tan. That would be the same thing as tan x plus y. So this means 100 plus 35. So this is what is tan of 135. So when we get to our unit circle here, 90, 45, so that'd be right here. So that's going to be the coordinate negative square root of 2 over 2, comma the square root of 2 over 2. So remember, tangent is the same thing as sine of 135 over cosine of 135. And in this case, this is the square root of 2 over 2 divided by negative square root of 2 over 2. Since they're the exact same thing with the negative, then I know my answer is negative 1. Had they not been, then of course I'm doing keep, change, flip. All right, so there you go with number 35. Let's look at number 36. Number 36 says sine of 125 degrees, cosine of 35 degrees, minus cosine of 125 degrees times sine of 35 degrees. So hopefully you see a sine cosine minus cosine sine is the sine of x minus y. So this would be 125 minus 35. And that would just give me sine of 90 degrees. And sine of 90 degrees, which is located right here, is the coordinate 0, 1. So that answer is just a straight up 1. All right, let's do another one. Let's look at 37. So this one is a tan 5 pi 16ths minus tan of pi 16ths divided by 1 plus tan of 5 pi 16ths times tan of pi 16ths. So again, I'm going to use my tangent function. And this will just be tan of x minus y. So this would be 5 pi 16ths minus pi 16ths. So when I do the math here, I get tan of 4 pi 16ths, which reduces down to tan of pi fourths. So when I come back over here, again, pi fourths is located right here. Square root of 2 over 2, comma square root of 2 over 2. So this just gives me square root of 2 over 2 divided by square root of 2 over 2 for my sine over cosine, which will just give me 1. All right, let's do another one. Let's look at number 38. 38 is cosine 15 degrees, cosine 15 degrees minus sine of 15 degrees times sine of 15 degrees. So again, if I have cosine, cosine minus sine, sine, that is going to be the cosine of x plus y. So that's going to be 15 degrees plus 15 degrees, which gives me cosine of 30 degrees. And at 30 degrees, which is located right here, that would be square root 3 over 2, comma 1/2. Cosine being x, my answer would be the square root of 3 over 2. All right, so let's do another one. Make sure you have one of every type. So let's look at number 39. 39 says sine of 70 degrees, cosine of 80 degrees, plus cosine of 70 degrees times sine of 80 degrees. Again, when I see a sine, cosine plus cosine sine, I know that this is going to be sine of x plus y. So that's 70 plus 80, which will give us sine. What is that? Sine 250. Nope, can't do math. 70 plus 80 is 150. There we go. All right, so then 150. So this is going to be, let's see, that's going to be 30 off from 180. So that's going to be located right here. So that'd be negative square root 3 over 2, comma 1/2. And so that means that sine would be 1/2. All right. Let's do another one. What number was that one we just did? 39. So let's look at number 40. All right, this one is cosine pi fifths times cosine 3 pi tenths minus sine of pi fifths times sine of 3 pi tenths. Again, when I see cosine, cosine minus sine, sine, I know that this is cosine of x plus y. So this is pi fifths plus 3 pi tenths. All right, I know this is the same thing as 2 pi tenths plus 3 pi tenths. So then I know that this is cosine of 5 pi tenths, which is the same thing as cosine pi halves. Pi halves is located right here, which is 0, comma 1, cosine being x. We have 0 as our answer. All right, one more of that type. So let's look at number 42. This will be tan 5 pi twelfths plus tan of 3 pi fourths divided by 1 minus tan of 5 pi twelfths times tan of 3 pi fourths. So again, I see that that's tan plus tan over 1 minus, so I know that's going to be a tan of x plus y. So that's 5 pi twelfths plus 3 pi fourths. And so I know that's the same thing as tan of 5 pi twelfths over, I mean, not over, but plus, that would be 9 pi twelfths, which then that tells me that's the same thing as tan of 14 pi twelfths, which is the same thing as tan of 7 pi sixths, which 7 pi sixths would be located right here. So 7 pi 6 will be right after that. Oh man, hold on, let's go back earlier. I think I messed up on one of those. I did. I think right here I said it was 4 pi thirds, but this was actually located right here, which would have made the actual fractions change. What number was that? 21? Yeah, but I don't think it would have mattered because of the multiplication. But this should have been, because that would have been closer to the y-axis, should have been here. That's where 4 pi thirds is. Because 5 pi thirds is right here. Right, because that would have been 8 pi 6. That would have been 7, 8, 9. Yep. Okay, so then this would have been negative square, negative 1/2 negative square root 3 over 2. So at this one here, this should have been a negative 1/2, which would have gave you still a positive square root of 2 over 4. And then this one would have been the negative square root of 3, which would give you the positive 6. So you would have still got the same answer, but make sure you catch that because sometimes if it's the signs will make a difference there. But in that one, it didn't. So I made a mistake and didn't even know. So make sure you go check that, and hopefully you're yelling at the computer going, you're in the wrong location. All right, so that makes me feel better about this part here. Well, hold on, where we're at, right here. So 7 pi 6 is located right here, which is again 30 degrees past 180 at 210. So 7 pi 6, that one there is again negative square root 3 over 2, comma negative 1/2. And if I'm looking at tangent, this is going to be negative 1/2 divided by negative square root 3 over 2. Keep, change, flip. So I'll keep the first fraction, change multiplication, flip the second fraction. So that will cancel. This will give me a positive 1 over square root of 3. Rationalize it. So this now becomes a square root of 3 over 3. I've never memorized the tangents because I know I can always work them out. But once you do it enough times, tangent only has about 3 answers anyways. All right, so there you go. So there's your answer for number 42. All right, a few more of a different type as well. So let's look at number 50. It says express each of the following as an algebraic function of x. So it says sine of arc tan of 2x minus arc cosine of 2x. It wants us to write it as an algebraic expression. So express each of the following in an algebraic expression of x. Alrighty. I see that this could be a sine function. Let's see. It says look at example 7. So let's quickly go look at that real quick. Okay. All right, so I'm going to kind of write this out as of u and v. So what basically you have to do here is we're going to say x is equal to the tan inverse of 2x, and y is going to be the cosine inverse of 2x. So when I rewrite this as sine of x minus y, I can write this out as sine x cosine y minus cosine x sine y. So what happens here is I have to build a triangle for each situation. So for the tangent one, so for this one right here, which deals with my x's, so we will write it like this. So we'll say, build our triangle here. We'll call this our x right here. So for tangent, tangent's OA, right? So that's going to be opposite over adjacent. So remember, any whole number can be written like this. So therefore, this would be 2x squared plus 1 squared, and then the square root of it. So this would be 4x squared plus 1. And the reason I just did that, here's some side work. This will be 2x squared plus 1 squared equals c squared. So that must be 4x squared plus 1. And then you would take the square root of that to get the c. So that's how I got to this point. And so then I would take that, and anywhere there was anywhere there's an x, I need to use that information. But let's go ahead and build the other fraction or other triangle as well. And this will be the y triangle. And again, cosine that would mean a cosine is the ca part. So this would be 2x. This would be 1. So now it's going to be, let's see, so a squared plus 4x squared equals 1. So that means that this would be the square root of 1 minus 4x squared. So again, I would subtract this over and then take the square root of that result. So then anywhere there's a y, that's what I would use. So what you got to do here is, here's my x, and then sine is OA. So that's 2x over this. That's 2x over the square root of 4x squared plus 1 times cosine of y. So cosine of y is adjacent. So that's going to be 2x minus cosine of x. So that's adjacent. So that's going to be 1 over the square root of 4x squared plus 1 times sine of y, which is opposite over adjacent. So that's going to be square root of 1 minus 4x squared over 1. All right, how simplified do we have to get according to your lost the page? Give me 1 second. When are we on 50? Here we go. All right, so they do want to write it as one gigantic fraction. So this will just become 4x squared over the square root of 4x squared plus 1 minus the square root of 1 minus 4x squared over the square root of 4x squared plus 1. The only other thing you got to do, since the denominators are the same, is we can finish this as 4x squared minus the square root of 1 minus 4x squared over the square root of 4x squared plus 1. All right, so a lot of work to do the exact same thing, and there's about 3 more type of these questions. So let's do another one to give you another example. Let's look at number 51. All right, number 51 says cosine of arc tan of 2x minus arc sine x. There we go. So that means that x would be the tan inverse of 2x, and y would be sine inverse of x. So we'll build our triangle for our x here. So tangent, again, is opposite over adjacent. So this is 2x over that. And again, using the Pythagorean theorem, I can see that this is just 4x squared plus 1. Build the other one for the y. Again, this is opposite over adjacent. So this is going to be x over opposite over hypotenuse. So this one here would just be 1 minus x squared, because again, I would square this, move it over, and then take the square root of that. All right, and so therefore this right here is really just written as cosine of x minus y, which is cosine of x cosine of y plus sine of x sine of y. So now when I work this out, cosine of x, that'd be adjacent over hypotenuse. That's 1 over the square root of 4x squared plus 1 times the y. So again, that's adjacent. So that's going to be a 1 minus x squared over 1 plus sine of x. So this will be this right here. So that would be opposite over hypotenuse. So this will now be 2x over the square root of 4x squared plus 1 times sine of y. Again, that's opposite over hypotenuse, so that's just an x. So when we work this all out, I can see the denominators are going to be the same. So I just get the square root of 1 minus x squared all of this will be over 4x squared plus 1 because that's what that is, plus that, technically over 1. So this will be plus 2x squared. You could do the second step in between that if you need to, but that would be what the final result would be. I just do another one to make sure you have this down pretty good. Let's look at number 52. This is cosine of cosine inverse of x minus sine inverse of x. So again, x would equal cosine inverse of x. Y would equal sine inverse of x. So this right here is the same thing then as cosine of x minus y, which again we just did. So that would be just cosine x cosine y plus sine x sine y. Alrighty, so here we go. So then cosine x. Oh, I gotta build a triangle. There's x. So that would be adjacent over hypotenuse. So that's x over 1. So this would then be the square root of 1 minus x squared. This is x1. So then this one would be 1 minus x squared. So then we work this out. Cosine of x would now be just x. Cosine of y would be times the square root of 1 minus x squared, plus sine of x, which would just be 1 minus x squared, times sine of y, which would just be x. Since I see that these are the exact same thing, I can just say, well, I have 2x square root of 1 minus x squared. And so that would be your final result there as well. All right. Last one, and you should have plenty of examples. So number 54 is sine inverse of x minus cosine inverse of x. So again, we'll just let x be sine inverse. And if you need to use different letters to help you not be so confused, I'm okay with that. I just like x and y because they look better than u's and v's. All right, so here we go. So I work this out. All right, sine is opposite over hypotenuse, so that's x1. This is then square root of 1 minus x squared. You do it enough times, you'll see the pattern as well. So this is y. Cosine would be x1, and then this one would be 1 minus x squared. This one then would be rewritten as x minus y. So therefore, I can write it as sine x cosine y minus cosine x sine of y. So when I work this out, sine of x is just x. Cosine of y is just x. Minus cosine of x is the square root of 1 minus x squared. Times sine of y, which is the square root of 1 minus x squared. Since these are the exact same thing, I can say this is x squared minus 1 minus x squared, because two square roots that are exactly the same will cancel out. Distribute this now becomes x squared minus 1 plus x squared, and you'll see that the x squares cancel, and you get something interesting, which is negative 1. Oh, I lied. Hold on. I got ahead of myself. Which is what happens had this been a negative. But since these are both the same, this is actually 2x squared minus 1. I have seen that happen, though, where it just becomes a 1 as the answer, which again is just so amazing. All right, if you need more examples than that, please reach out. Other than that, I'll see you in the next video.